Hi everyone. Thank you for attending the BAS Electrochemical Webinar 2021 January. I'm Miho, representing BAS International Sales Team, and I will be the moderator. Before we start, we'll ask you to don't be worried to record and enjoy the webinar. We are recording, and we will send the direction to you as soon as it is ready. In this way, you will be able to review the full webinar. Also, if you have any question, please feel free to contact us. In addition, in the technical note of ALS website, you can find explanatory material on the electrochemical and spectroelectrochemical research field, and the movies of the variety of topics you can watch here in the BAS channel, which you can follow and have access to the latest news, including the full first BAS webinar. This was holding last year. Well, let's stop the announcement and start the lecture, which everyone is waiting. Dr. Jiang, her topic is Introduction to Spectroelectrochemistry and Basic Measurement Examples.
Hello everyone. Today's topic is Introduction to Spectroelectrochemistry and Basic Measurement Examples using the SEC 2020 spectrometer system. Let me show you the contents we will talk about. At first, I'd like to explain what's spectroelectrochemistry, background, history. Second, the principle, features, and application of spectroelectrochemistry. And then I will show you the typical SEC techniques, include ultraviolet visible absorption SEC, cell, and electrode. Following, I will introduce the measurement methods of spectroelectrochemistry using SEC 2020 spectrometer system and Model 2325 biopotential stat as example. Explain step by step from setup of the instruments to software operation methods. You can know how to create a basic absorbance measurement and give example of time-lapse measurement for recording specific wavelengths or the entire wavelength range. Finally, an experimental example of monitoring the time course of absorbance with constant potential electrolysis using a potassium ferrocyanide solution is shown. First, let's see what's spectroelectrochemistry. It's a measurement which combined the spectroscopy measuring method with the electrochemical measuring method simultaneously. It can be abbreviated as SEC. It is often difficult to understanding the phenomenon that actually occurs at the electrode-solution interface simply by measuring the relationship between the electric current and the amount of electricity and the electric potential. Therefore, spectroelectrochemical methods have been developed. The history of spectroelectrochemistry can be traced back to 1954. Shikata has said that research must be interconnected, and foreseeing the importance and development of spectroelectrochemistry. The first spectroelectrochemical experiment was carried out by Kuwana in 1964. In situ measurement of the electrode reaction product using a transparent electrode was carried out. Development and improvement were made by many researchers then. Nowadays, ultraviolet visible absorption spectroscopy is the most well-known method. And with the development of spectroscopy technique such as reflection, Raman, EPR spectroscopy are applied. Techniques on which the SEC is based are electrochemistry and spectroscopy. Electrochemistry studies the interaction between electrical energy and chemical changes. This technique allows us to analyze reactions that involve electrotransfer processes. On the other hand, spectroscopy studies the interaction between electromagnetic radiation and matter. This figure shows the often used techniques. Ultraviolet visible absorption spectroscopy is the most well-known method, and the spectroscopy is combined with electrochemistry techniques, for example, coronal amperemetry, coronal potentiometry, and voltammetry. By SEC measurement, we can know the reaction on the electrode surface, the interface of an electrode and solution, and the electronic state of a molecule, the absorbance of reactant, product, and mediator, thereby to a substance that difficult analyzed by electrochemically. The redox potential can also be computed from the absorbance if the reactants or products have spectrum characteristic. Furthermore, when an electrode system is at an equilibrium situation or a stationary state from SEC measurement, identification of the molecule species and analysis of a molecule structure are possible. The chemical species near electrodes can be identified by absorbance and spectrum. The basic spectroelectrochemical methods in the ultraviolet visible regions are mainly used. The typical methods are transmission method and reflection method, as shown here. In the transmission method, classified by the relationship between the arrangement of the optical path and the electrode and the thickness of the solution phase. A and B, light transmit electrode surface vertically, therefore we need optical transparent electrode. The difference is solution thickness. C, light passes through the thin layer solution parallel to the electrode surface. Therefore, it has a long optical path and thin layer solution phase. In the reflection method, D, light is incident from the inside of the electrode and reflected on the electrode surface, called internal reflection. E, light is incident from the solution phase and reflected on the electrode surface, called specular or external reflection. The transmission method is often used because of the simplicity of the experiment. From now on, I will mainly explain the transmission method. At first, let's see the electrode used for SEC. The most common transparent electrode is glass or quartz coated with conductive film or oxide or metal. Grid or porous electrodes are also used as transparent electrodes. Here we show the transparency of different electrodes. Oxide semiconductors, thin film, such as BAS product, titanium-doped indium oxide, ITO electrode, shows good transparency, but not in UV region, because it's limited to interband transitions in semiconductors. Comparing with the ITO, grid or porous electrode, for example, the grid electrode of BAS products. Since light passes through the gaps in the grid, it can be used in entire wavelength range. Transparency depends on mesh and the wire diameter, and BAS mesh electrode has higher transmittance comparing to the grid electrode. Next, let me introduce the cell used for SEC. Sandwich cells are most commonly used in the optical transparent electrode method. Grid or porous electrodes are also used as optical transparent electrodes. Here we show you the basic structure of the cell. Light transmits the cell wall, electrolyte, and electrode surface vertically, detected by a spectrometer or other detectors. BAS products, cuvette type and flow type cell, they are sandwich structure also. The core cell includes a mesh working electrode, and the flow cell is used with ITO and grid electrodes. From this page, I'd like to show you the instrument setup and measurement steps using SEC 2020 spectrometer system and model 2325 bipotential stat. The instruments for SEC measurement includes an electrochemical analyzer, spectroscope, and we need a transmission electrolytic cell and control software with PC. Let's look at the instrument setup actually. This is SEC 2020 spectrometer system including light source, spectrometer, and cell holder. Thin layer quartz glass spectro-electrochemical circuit transparent electrode is set in the cell holder. It comes with mesh electrode, counter, and reference electrodes also. This is a model 2325 bipotential start. For synchronized measurement, we use a cable to connect a spectrometer with model 2325. Bipotential start output external TTL signal, and SEC 2020 spectrometer system receive external input signal under acquire spectrum. The SEC spectral software controls the data acquisition in the following two ways: by changing of the external TTL signal applied to the I/O port of the SEC 2021 spectrometer. In the case of a software level trigger, the measurement starts when the external input TTL signal changes from low level to high level, and stops when the external input TTL signal changes from high level to low level. In the case of software continuous trigger, the measurement starts when the external input TTL signal changes from low level to high level. But when it changes from high level to low level, the measurement doesn't stop, and it is designed to measure continuously until stopped by software. By using trigger mode, if the external device is set to output the TTL signal at the same time as the electrochemical measurement starts, the SEC2020Y spectrometer accepts the input signal and will start the data acquisition at the same timing. Model 2325 can output TTL signal as a mode of software level trigger controls start and stop both. This page will show you the detailed connection. First, connect the trigger cable to the SEC2021 spectrometer. For model 2325 bipotential start, connect D ground of the I/O port to the ground terminal of SEC2021 spectrometer, and connect VRDE to the trigger in terminal respectively. Turn on the power of model 2325. Here shows the setup of SEC2020 spectrometer system for absorbance measurement. First, set the spectrometer and light source. Connect the fiber collimator to the cuvette holder and connect it to the spectrometer. Fix it with the platform screws on the platform. Attach the collimator with inner cylinder removed to the cuvette holder at opposite side, and install the light source so that it enters the collimator. Fix with the platform screw at the position. The completed setup shows in right. Turn on the power switch of light source and turn on the D2 and halogen lamps. Open shutter. Wait for 20 to 30 minutes until the light source stabilized. I will show you how to create an absorbance measurement. Connect SEC2020 spectrometer to PC. Insert a cuvette including reference solution into the cuvette holder. Here we use a SECCT thin layer quartz glass spectroelectrochemical cell kit including potassium chloride solution. Start software by click on the icon. The spectrum gel is created automatically. You need to adjust integration time, average, and boxcar to a suitable range. Select Absorbance from the measurement menu and open the new Absorbance measurement window. On the source device window, show the source device, then click Next. Set the data acquisition related parameter on the screen Adjust integration time, average, and boxcar to a suitable range. Click Next. To acquire a reference spectrum and then dark spectrum, close the shutter of SE2020/source. Click Next. You can specify a name for the measurement graph window and title and color. Click Next. The measurement graph is displayed. The absorbance of reference solution is near zero. Okay, the absorbance measurement is ready. Normally, here you need to replace the reference solution by a sample solution. In this case, we replace to a potassium ferrocyanide solution. If you set potassium ferrocyanide solution as a reference in the previous step, then you can view the absorbance change during electrolysis. Let me show you the scene in video. Insert the SEC cell includes potassium ferrocyanide solution into the cuvette holder. Now here is the absorbance. We can adjust the scale to show the spectrum in focused wavelengths. The specific wavelengths are near 300 and 420 nanometer. Next, we need to set the trigger mode of the SEC spectral software. Select Trigger Settings from the Setting menu. Click on the serial number. Select your trigger mode. In this case, we use software level trigger. Click the Enable button to put the measurement into the trigger mode. Click OK to exit this window. You will notice that the spectrum signal not change anymore because it is waiting for the external signal to start data acquisition. In the spectrum list pane, you will find that the acquisition mode is software level trigger mode. To create a time-lapse measurement for recording specific wavelengths, please look at the video. Select Strip Chart from the Measurement menu. Select Target Spectrum. Here we use Absorbance 0. And then set the specific wavelengths. Here we input, for example, 300 nanometer. Click Add. It will be added to the list. Next, you can add another wavelength, for example, 420 nanometer. Click Add. And click Record Setting to open the setting window. Set the data acquisition interval, for example, every 1 second here, and when to stop, for example, stop after 100 seconds. Click OK to return to previous window. Click OK to next step. Set window name. Click OK to create a new strip chart window. The spectrum signal not change anymore because it is waiting for the external signal to start data acquisition. SEC Spectrum provides a time sequence function that records changes in entire wavelength range. Please look at this video. show the time sequence window, click on the pushpin icon on the upper right corner to fix it. Select Target Spectrum Absorbance. Specify the folder to save the recorded data. Specify the start time. Here we use default setting start after first data. Set interval for the recording. Set the stop time. Next, whether create file at every data tracking interval. And then press the record button to start the record. Click OK here. Set the model 2325 to output TTL high-level signal during the measurement. Open software of model 2325. In the setup screen, check Rotate RDE under During Run. Enter rotation speed of RDE settings as 3000 and click OK. Set amperometry measurement conditions. For reduction electrolysis of potassium ferricyanide, set the initial potential at 0 volt. Start SEC measurement. Click Run of Model 2325 to start amperometric. In the same time, output TTL high-level signal during the measurement. Please look at the demonstration measurement video. Click Run of the Model 2325. The spectral signal on the SEC spectral software screen starts to move in conjunctions, and the time course of absorbance is recorded according to the conditions set in. You can see the absorbance decrease with the reduction electrolysis of potassium ferricyanide. As we set to software level trigger, absorbance measurement will stop automatically when the measurement of model 2325 is completed. The spectrum signal is stopped now. After stopping the measurement, you need to click on Save icon in Strip Chart window to save the recording results. For time sequence measurement, the recorded results are saved in a preset folder. You can load the data to compare the results from File Open Spectrum File menu. In time sequence setting, if you uncheck Create File at every data tracking interval, the spectrum should be recorded as a video, and you can load the recorded results from File Open Time Sequence File menu. At last, let me summarize today's topic. Spectral electrochemistry is a measurement which combined the spectroscopy, mirroring method, with the electrochemical mirroring method simultaneously. Using the trigger mode of the SEC 2020 spectrometer system makes it easy to get the synchronized SEC measurements. BAS offers qubit type and flow type SEC cells with ITO, GC, PT, and AU electrodes to meet your electrochemical purpose. Thank you for your attention.
Thank you, Dr. Jiang. I wish you enjoyed the lecture. If you have any question regarding to the lecture or other topic, please feel free to contact us. The email is here. Also, you can reply from the email sent to you. In addition, in ALS website, you can find the products showed in the lecture, including the information about the new products. Thank you again and stay safe and healthy.